The electronic instrument panel and tractor performance monitor are designed to provide essential information about the tractor and implement, information that will help an operator work more efficiently and avoid damage to the tractor. Understanding how the electronic instrument panel and tractor performance monitor operate and what their displays mean will allow you to advise customers and service these devices more effectively. In this Trac Com program, we'll look at how the electronic instrument panel and tractor performance monitor, EIP and TPM for short, work. Then we'll discuss programming these devices and troubleshooting them when they fail to operate as they should. If you work on TW or 4 or 6 cylinder Series 10 tractors, you can expect to run across the electronic instrument panel. The EIP is standard equipment on the TW25 and 35 and optional on the TW5 and 15. The instrument panel is also optional equipment on 4 cylinder Series 10 tractors as well as on the 8210. But no matter which tractor the EIP occurs on, its layout is the same. At the top of the electronic instrument panel is the warning and indicator light section. It operates with other sections to warn the operator of a concern or to indicate the status of a system. At the bottom of the EIP are rocker switches for operating lights and engaging the front wheel assist. The switches for hazard warning and front wheel assist glow when these features are in use. In the middle of the EIP is the central display module. On the right-hand side of the module are touch-sensitive switches, a digital display, and an engine RPM bar graph. The switches allow an operator to monitor engine, PTO, and ground speed on the digital display. The ground speed switch can also provide the operator with a ground speed calibration number. In addition to providing information through the use of the switches, the digital display also flashes warnings and self-diagnostic messages to aid in troubleshooting. Meanwhile, the engine RPM bar graph continuously displays RPM whenever the engine is running. On the left-hand side of the central display module are bar graphs. These use a liquid crystal display to indicate coolant temperature, oil pressure, battery condition, and fuel level. They also aid in troubleshooting by indicating when a concern is occurring in their circuits. Below the digital display is an hour meter, similar to those in use on other instrument panels. The hour meter measures engine running time in true hours. In addition to the visual displays and indicators in the EIP, an alarm warns of possible concerns in the tractor. To collect the wealth of information it provides, the electronic instrument panel uses a number of senders and switches, which we'll refer to as input devices. We'll look at these devices as they occur on a TW tractor. For information about differences in location and operation on other tractors, see the reference manual accompanying this program. The first input device we'll look at relays information about engine speed. On a TW tractor, as well as on the 8210, the engine speed sender is mounted on the back of the fuel injection pump. The rotor in the sender is driven by the pump and creates pulses which are sent to the EIP. The EIP then converts the pulses into RPM readings. On this side of the engine are the engine oil pressure switch and sender. The engine oil pressure switch is a simple on-off device that opens when oil pressure rises above 10 psi. But the oil pressure sender is more complicated. The EIP monitors a 5-volt signal it sends to the oil pressure sender. Variation in oil pressure causes the voltage to change, causing the EIP to change the readouts and warnings accordingly. The next two input devices we'll look at, the coolant temperature sender and switch, operate in much the same way as the devices used for oil pressure. On TW tractors, These devices are located in the side of the thermostat housing. The engine coolant temperature switch closes when coolant temperature rises above 121 degrees centigrade. The coolant temperature sender varies in resistance with temperature. The changes in resistance are relayed to the EIP, which operates the bar graphs and warning indicators accordingly. Further back, in the air intake tube, is another input device, the air filter restriction switch. The air filter restriction switch closes when vacuum in the air intake tube exceeds 30 inches of water, indicating a dirty or clogged air filter. The EIP monitors conditions in the transmission in much the same way it does in the engine. On a TW tractor, the transmission oil temperature and pressure switches are located on the right-hand side of the tractor. The oil pressure switch is located in the dual power hydraulic line at the upper edge of the transmission, and the oil temperature switch is in the hydraulic pump cover. Both of these switches operate in the same manner as those we've already looked at, but the oil pressure switch is normally closed and the oil temperature switch is normally open. On the opposite side of the transmission, from the transmission input devices, is the axle speed sender. The sender uses a pickup coil close to the front wheel assist gear coupling. The action of the gear close to the pickup creates pulses which are relayed to the EIP. The EIP converts the frequency of the pulses into ground speed. The handbrake warning switch is located beneath the handbrake assembly. This is a magnetic switch that opens with the handbrake lever lowered and closes when the lever is engaged. It accomplishes this through a metal tab that prevents the switch from closing when it is positioned between the magnet and the switch contacts. While we're in the area, let's take a look at the input for charging system voltage. The sender wire for regulated voltage receives its signal from the voltage regulator. On a TW tractor, the regulator is separate from the alternator and is mounted near the right-hand step bracket. The final input devices for the electronic instrument panel are the fuel level senders. These senders operate in the same manner as those on other tractors, by varying resistance through the movement of a float. When a tractor is equipped with both senders, the EIP averages out the readings so the portion of total fuel remaining is displayed on the bar graph. Other components connected with the electronic instrument panel include the tractor wiring harnesses and connectors. For more information on these, see the wiring and connectors section of the reference manual. Understanding what the EIP displays mean is a key part of servicing the electronic instrument panel. The displays can be divided into those which occur under normal operating conditions, those which occur as a warning of a concern in the tractor, and those which indicate a concern in the EIP or its circuits. Under normal operating conditions, when the key is first turned to the on position, the warning lights that are not ordinarily lit light for 2 seconds to show that their bulbs are working. The 4 bar graphs display all segments for 2 seconds before displaying actual conditions. The rocker switches indicate whether the hazard warning lamps are on or the front wheel assist is engaged. And the digital display runs its various types of readouts for 2 seconds as a self-check. It's then ready to display engine RPM. When the engine is started and the tractor is operating within the limits programmed into the electronic instrument panel, the lights at the top of the EIP indicate which devices on the tractor are in use, while the bar graphs display coolant temperature, oil pressure, charging system voltage, and fuel level. The segments displayed correspond to temperature, pressure, voltage, and fuel level ranges, which are specified in the reference manual. After the engine is started, the digital display and bar graph indicate engine RPM, but an operator can use the switches to the right of the display to allow ground speed or PTO speed to appear on the digital display. The symbols displayed, RPM or miles per hour, change accordingly. Except on the TW35, which uses only a 1000 RPM PTO, depressing the PTO speed switch again changes the display to correspond to a different PTO speed range. When the electronic instrument panel senses that a system is not within normal operating limits, it uses a variety of warnings to indicate this to the operator. Let's look at one of these conditions: low engine oil pressure for a given RPM. When a tractor engine is running and engine oil pressure is too low for the engine RPM, the low engine oil pressure warning lamp lights. One segment of the oil pressure bar graph flashes slowly. A stop message flashes slowly on the digital display, and a continuous alarm sounds. The electronic instrument panel uses a different set of displays to indicate a concern in the EIP sender circuits or in the EIP itself. Let's look at one of these concerns: engine oil pressure sender circuit open. When the oil pressure sender circuit is open, the EIP senses that the voltage signal has been interrupted. With the key on, but the engine not running, all of the segments on the engine oil pressure bar graph flash rapidly. At the same time, open appears in the digital display. When the engine is started, the digital display changes to stop, and a continuous alarm sounds. The bar graph continues to flash rapidly. You can see why a familiarity with the electronic instrument panel displays is important. Without it, it's difficult to tell the difference between a display that indicates a concern in the tractor and one that indicates a concern in the EIP or its circuits. The reference manual accompanying this program contains charts which will help you tell the difference between displays used to warn of a concern in the tractor and those that indicate a concern in the EIP or one of its sender circuits. During our discussion of the electronic instrument panel, you may have noticed the screen and set of switches to the right of the central display module. This is the tractor performance monitor. The TPM is optional on all of the tractor models the electronic instrument panel is available on, and it can be a factory or dealer installed accessory. The switches at the bottom of the TPM console allow an operator to obtain readouts which appear in a liquid crystal display on the screen. The switches are also used to program and calibrate the TPM. In addition to readouts, the performance monitor uses the electronic instrument panel's alarm to inform the operator when preset limits have been exceeded. Like the electronics instrument panel, the tractor performance monitor uses input devices to supply its computer with information. The first device is one you've already seen, the axle speed sender. In addition to providing the electronic instrument panel with information, it also provides a signal to the performance monitor so that it can calculate wheel slip. The TPM does this by comparing axle speed with actual ground speed. You may be wondering how the TPM obtains actual ground speed. The answer is this device, the radar ground speed sensor. On TW models, the sensor mounts on the right-hand side of the tractor frame. On Series 10, four-cylinder tractors, and on the 8210, the sensor is mounted on the left-hand side of the transmission housing. For obtaining information about whether an implement is raised or lowered, as well as for establishing beginning and end points for area calculations, the TPM relies on an implement status switch. On TW tractors, the switch operates by a pull chain attached to the three-point hitch lift arms. This type of switch is easily remounted on a trailing implement. On Series 10, four-cylinder tractors, and on the 8210, the implement status switch is mounted on the lift control lever. It uses a plunger to open and close the contacts in a micro switch. The wires from the radar speed sensor plug directly into the back of the electronic instrument panel, while those for the implement status switch and axle speed sender are routed to the tractor wiring harnesses. The wires then run to the rear main harness. The tractor performance monitor plugs into the rear main harness by means of an 8-pin connector. Now let's take a brief look at the displays the TPM uses to keep the operator informed of conditions. When the key start switch is first turned to the on position, the TPM runs through a self-check as it displays all of its messages. The performance monitor then displays the time and switches to the operating mode. When the tractor performance monitor is in the operating mode and the operator touches the switches at the bottom of the console, the TPM displays the time of day, the area that will be covered in an hour by the implement, the amount of wheel slip, and the accumulated area covered by the implement. Once the accumulated area figure reaches 9,999 units, it automatically rolls over to 0. A repeat touch of the area switch synchronizes the implement up readout with the actual implement position, and holding the area switch down for 5 seconds returns the accumulated area reading to 0. Similarly, holding down the slip switch zeroes the wheel slip function. In addition to these displays, the TPM displays the word alarm and sounds an alarm when a preset time, area or wheel slip limit is exceeded. Touching the time of day switch cancels the alarm for this function. In the next segment of this Trac Com program, we'll cover using the setup mode of the tractor performance monitor to set the alarm and calibrate the TPM. Occasionally, when replacing an electronic instrument panel or assisting a customer, you may need to program or calibrate the EIP. Programming the electronic instrument panel is simply a matter of setting the 4 switches on the back of the panel. The position these switches are placed in depends on what model the tractor is, how many fuel tanks it has, and what units, metric or English, the operator wants the displays to be in. Charts in the Trac Com reference manual contain switch positions for all tractor models equipped with the EIP. Calibrating the electronic instrument panel to display the correct ground speed is necessary if replacement tyres are more than 1/2 inch different in rolling radius from the original tyres. Calibrating the EIP is a matter of finding the rolling radius of the rear tyres, matching that radius with a calibration number, and entering that number in the electronic instrument panel's memory. To find the rolling radius of the rear tyres, first park the tractor on a hard level surface and make sure the tyres are inflated to the correct pressure. Then carefully measure the distance between the middle of the wheel hub and ground. Next, use the chart in the reference manual or tractor repair manual to find the calibration number. Turning the key start switch on and holding the ground speed selector switch down for 5 seconds causes the existing calibration number to be displayed. If this number is different from the number you arrived at by measuring the rolling radius, the EIP has to be recalibrated. To do this, first remove the 4 attaching screws from the panel to gain access to the calibration knob. Then rotate the ground speed calibration knob until the correct number appears on the central digital display. Once the electronic instrument panel is reinstalled, pressing any of the selector switches momentarily returns the EIP to normal operation. If a tractor is equipped with a tractor performance monitor, finding and entering the calibration number in the manner just described is unnecessary. However, the TPM does require other information to do its calculations and sound an alarm when the preset limits are exceeded. Let's take a look at this process from start to finish. Entering information into the tractor performance monitor requires switching to its setup mode. To do this, turn the key start switch to the on position and wait for the screen to display a readout. At this point, the TPM should be in the normal operating mode. Next, press down the setup switch for about 3 seconds. Setup should appear in the upper right-hand corner of the screen. At this point, touching the setup switch momentarily advances you to the next step in the programming procedure. Holding down the switch for about 3 seconds returns you to the operating mode. To return to the setup mode, simply press down the switch for another 3 seconds. When you enter the setup mode, the first item you're asked to program is the units of measure. If the display is blank, the units of measure are English. Pressing the slip switch momentarily changes the units to metric and causes metric to be displayed on the screen. Another touch of the slip switch turns the units back to English. To advance to the next area, implement width, momentarily touch the setup switch. Then, using the digit select switch to select the digit to be changed, and the digit set switch to assign a new value in place of the old one, enter the implement width to the nearest tenth of a foot. Once the implement width is correct, press setup once again to advance to the preset area function. Use the digit select and set switches just as you did for implement width to preset the accumulated area. This is usually 0, but using this function, a maximum of 99.99 units can be preset as an area to be added to. With the preset area function completed, touch the setup switch momentarily to advance to the next function, time of day. To set the time, use the digit set switch to advance the hours. Then, use the digit select switch to change over to minutes. After using the digit set switch to set the minutes, momentarily touch the setup switch to read the time alarm. The point at which the time alarm sounds can be set using the digit select and digit set switches. The procedure is the same as for setting the time. If the alarm is not needed, use the switch marked on/off to cancel the alarm. The status of the alarm is displayed on the screen. Pressing the setup switch now takes you to the slip alarm. Preset the slip alarm using the digit select and digit set switches. If the alarm is not needed, use the on/off switch to cancel it. At this point, pressing the setup switch momentarily takes you to the distance calibration function of the tractor performance monitor. In this function, the monitor uses a measured distance to match the calibration of the console to the readings from the radar ground speed sensor. This is similar to measuring the rolling radius of the tire and entering a calibration number in the EIP when a tractor is not equipped with a TPM. The measured distance is 400 feet, and it should occur on a course that runs over hard, level ground. In order for the performance monitor's distance calibration to be accurate, it's important that the start and finish are marked accurately. Next, drive the tractor toward the start of the course at approximately 5 miles per hour. Press the on/off switch when passing the start marker and maintain the slow, steady speed over the course. 3 dashes should now be displayed on the TPM screen. As you pass the 400-foot marker, press the on/off switch again. At this point, the TPM displays the distance calibration number. On this TW tractor, the number is 86. After entering the distance calibration number, the next step in the setup is verifying the distance calibration. This simply means checking the distance calibration to make sure that it will result in accurate distance readings. To begin the verification, push the setup switch once more. The TPM will clear the calibration number and display zeros on the screen to signify that it is in the verification part of the setup procedure. Once again, you'll need to use a 400-foot course, but for the sake of accuracy, it's a good idea to measure off a different course than the one used to obtain the calibration number. Drive the course just as you did to obtain the calibration number. Use a slow, steady speed and press the on/off switch at the beginning and end of the course. At the end of the course, the performance monitor registers the distance it has calculated the tractor covered on the course. If this is within 4 feet of the 400-foot figure, the TPM is calibrated correctly and you can press down the setup switch for 3 seconds to return to the operation mode. If the distance is not within these limits, you'll need to repeat the procedure described earlier to determine the calibration number. When advising customers on setting up their performance monitors, it's a good idea to remind them to set wheel slip to 0 while driving the tractor with the implement raised over the type of ground to be worked. This allows them to obtain accurate wheel slip readings when working the same type of ground with the implement lowered. See the reference manual accompanying this program for further information about zeroing wheel slip. When the electronic instrument panel or the tractor performance monitor fail to operate as they should, it's important to make use of both the self-diagnostics and a comprehensive troubleshooting procedure. Otherwise, there is always the danger that parts replacement will become a substitute for troubleshooting. It is also important to follow a few general precautions and practices when testing and repairing the system. These include isolating the EIP from resistance checks made on switch or sender circuits. Resistance checks may damage the sensitive electronic circuits in the EIP. When checking circuits, be sure to use a good multimeter that has an input impedance of at least 20,000 ohms per volt. This helps protect sensitive circuits. When cleaning the connectors in the system, use an electronic contact spray, but do not use a cleaner that contains trichloroethylene. This chemical can dissolve the plastic used to make the connectors. And after cleaning contacts, smear the terminals with a dielectric grease to prevent corrosion and ensure a good contact. With these precautions out of the way, let's look at troubleshooting a concern indicated by the self-diagnostics of the electronic instrument panel. Suppose, for example, that the instrument panel is indicating an open in the fuel tank sender circuit. The first step in troubleshooting is to check the connection at the fuel tank sender. If this is all right, remove the sender wire to the EIP and connect it to a good ground while observing the EIP display. If the EIP indicates a short circuit when the key is turned to the on position, it indicates the circuit is all right up to the sender and that the instrument panel self-diagnostics are accurate. You'll need to continue troubleshooting by checking the resistance between the fuel level sender terminals. If the resistance is close to the specification for the amount of fuel in the tank, the sender unit is working properly, and the cause of the open is probably in the sender ground. If the resistance reading does not coincide with the amount of fuel in the tank, the sender should be replaced. But suppose that earlier in the troubleshooting procedure, when the signal wire from the sender was shorted to ground, the EIP did not display a short circuit symbol. Well, in that case, the cause is probably in the sender wire or in the EIP itself. And you'll need to remove the instrument panel and disconnect connector A. With A disconnected, once again disconnect the connector at the fuel level sender and ground the sender wire which transmits the signal to the EIP. Then check the resistance between pins A3 and A6 on connector A. If the resistance is greater than 10 ohms, there is an open in the circuit between connector A and the fuel level sender connector. You'll need to track the open down and repair the wire. If, with the sender wire grounded, the resistance reading between A3 and A6 is less than 10 ohms, it indicates either a bad connection at the connector or a concern in the EIP central display module. To check the connector, clean the connector pins, apply dielectric grease to them, and reconnect connector A. If the EIP still doesn't function properly, install a replacement central display module in the instrument panel and check the operation. Troubleshooting other self-diagnostic circuits is similar to the procedure just described for the fuel level sender circuit. The non-self-diagnostic switch circuits use a common test for detecting the cause of a concern. All of these procedures, as well as procedures for troubleshooting the tractor performance monitor, are contained in the applicable tractor repair manual and in the reference manual accompanying this program. In this Trac Com, We've looked at the electronic instrument panel and tractor performance monitor, two features of Ford tractors designed to take some of the work and worry out of farming. Applying the information contained in this program, using the system's self-diagnostics, should help you take some of the work and worry out of service as well.